Hello, my darlings. Today's lesson is on observations, inferences, claims, and reasoning. Your success goal is that by the end of this video, you will be able to differentiate observations, inferences, claims, and reasoning from each other. Let's get started. Okay, so if I were to show you a photo like this and ask you to make observations, I sometimes hear things like, oh, that's a cute little puppy, like that's so cute, or the puppy's cold, or things like that. Now, these are in fact not observations. And so today we're going to be looking into what are observations actually, and then what are some things that can come out of those. So when we talk about observations or evidence, we're talking about things that we can see, that we can hear, that we can touch, that we can taste. Only sometimes in science, but you get the idea. So when we talk about observations or evidence, what we mean is information gathered through the senses or measurement. So to be more scientific about this, we can actually divide observations into two types. We have quantitative observations and we have qualitative observations. Now, quantitative observations are made using tools like rulers, scales, beakers, etc. This is going to be observations that involve numbers. I like to use the name itself as a little bit of a clue here. So the first part, quantit, that looks kind of like quantity. And quantity, if you're talking about the quantity of something, you're talking about how many. Qualitative observations, on the other hand, are made using your senses. And again, I like to use the word to remind me. Qualitative, the first part, qualit, looks like quality. So if you were to kind of describe the quality or like the characteristics of something. So some quantitative examples are things like temperature, right? How long something is, volume, which we've talked about before, mass, which we've talked about before, density. But you can also think about something like salt dissolved in water. How much salt could dissolve in water, right? If you're looking at how much, that's a number. And if you're looking at numbers, it's quantitative. Now, qualitative examples, remember, are describing more of like the quality of something, right? So for example, we have color. We might have something like smell, taste, using your senses, right? Over here, this is a hand. You can't see it very well, but it's a hand touching a tree. So you might have something like, how does it feel? Its texture. Here you see, if you compare these two, we're looking at like the clarity, how clear is it, right? That's something I'm just describing with my eyeballs. It might be something like the malleability of something or how easily it breaks. So now that we've defined observations, let's get some practice with this. So here we have an example. What observations can you make about this animal? Okay, hopefully you did good on that first one. Here's another example. What evidence do we have about this substance? Now, we also have something called inferences. Inferences are a little bit different than observations. As you can see here, in an inference, you take what you have observed and you're going to process that in order to come up with what you think is true based on those observations. So returning to our example from before, what inferences can we make about this animal? And what inferences can we make about this substance? Now, inferences are going to be something that can help us to develop a scientific claim. So what is a scientific claim? Well, a scientific claim is a statement or conclusion that answers the original question that can be backed up with appropriate and sufficient evidence. So we have a couple parts to this, right? A claim should answer the original question, And it also should be something that you can support using your evidence. So based on the observations that you saw in your experiment, what is a conclusion that you can draw? So we've talked through a couple steps here. So let's try to apply these multiple parts to a new example. What happened here? That's our question that we're trying to solve. We start off with just observations. I can see that there is a bike stuck in cement. I see that we have footprints that are in front of the bike. There are lines in the cement behind the bike, right? These are just things that I can see, touch, or feel. Now from that, I can start to draw some inferences. A person was maybe riding the bike. That's an inference. The bike made lines in the cement. Maybe those came from the bike. That's an inference. The person had to get off and walk, making the footprints. That's an inference. Now, my observations and inferences can finally lead to my claim, right? My conclusion to answer that question, what happened here? I think a person was riding their bike on the cement, maybe when it was wet, and then they had to get off the bike and walk, leaving their bike behind stuck. Now you maybe notice that in that case, one single claim was connected back to many inferences that I had made based off of my observations. That's totally fine. Your claim should be more sophisticated than an inference. Now finally, our last part of a scientific explanation is going to be reasoning. Reasoning are ideas that allow us to connect the claim to the evidence. We can use both existing knowledge that we have and new knowledge, maybe that we gain through our experiment. So we ask questions like, why does the evidence support the claim when making our reasoning? This should be a scientific explanation. Now, sometimes students struggle with this part. So you kind of want to think about like, if a textbook were to explain the science behind something, how would a textbook explain it? So going back to our bike example here, I've added reasoning. You'll notice that the reasoning is longer than the rest of it. That is how it should be. Your reasoning is where you should go the most in depth. As matter changes from liquid to solid, it can sometimes appear to be fully transitioned before it actually is. Liquids have molecules that are spaced out enough that material can move through them. Therefore, the bike was able to sink through the still liquid cement and got stuck as the cement was transitioning to a solid. Now you'll notice that this reasoning does talk about some of the observations that I made, right? The bike stuck in the cement, the lines in the cement behind the bike, right? But it's explaining. It's giving that like scientific explanation that is helping our observations connect to our claim.